Welcome, guys, to Unit 8 of your chemistry packet, which is stoichiometry. Miss seeing you guys, but we'll see how this works, and we'll try to see if you can hear a little bit from me in this. But stoichiometry is something that scares a lot of chemistry students. Don't let it scare you. The information here is not, all it is combining all of the stuff that you've gotten so far. It's simple as what this says right here. Finding the amounts of the reactants and the products in a reaction. So what can we do with stoichiometry? So last semester, last period, I'm sorry, this is a little off, we looked at how to balance a chemical equation, what a chemical equation is. With this unit, we're going to take this chemical equation and we're going to find the different parts of it. So if I tell you how much reactant you have, one of the things you're going to be able to do is tell me how much reactant needs to react with it. Or if I tell you how much of either one of the reactants, you can find out how much product you can make. Or if I tell you how much product you need to make, you can tell me how much reactant you need. If you notice, this is the part of chemistry that really people do every day if they say they're a chemist. You know, if you're working at a company and you need to make a certain amount of product, you need to order the exact amount of reactant or else you'll lose money. So this is a good way for, this is what chemists do in the real world. All right, so let's show you a different example. If that doesn't make any sense, here's something that does make sense for you. All right, so we all know what a Big Mac looks like. McDonald's is still open, so you can still get takeout. A Big Mac is 3 pieces of bread with 2 patties and then some extra ingredients mixed in. So if you work at McDonald's, you know that to make a Big Mac, these are the ingredients you need. So here's my question. If you have 4 patties, how much bread do you need? Well, let's look at this. 2 patties for 1 sandwich. 4 patties would mean 2 sandwiches. You would need 2 times 3, 6 pieces of bread. And in doing that, you'd be able to make 2 Big Macs. Now, something you'll see a lot in this unit is the word excess. Excess means you're not going to run out. Excess means that you have enough. You're not going to run out of that. And so let's see, we had excess patties. We're not going to run out of patties, and we have 18 pieces of bread. How many Big Macs can we make? So let's look at this. 18 pieces of bread. It takes 3 to make 1. So 18 divided by 3, you can make 6 Big Macs. Pretty cool. And then finally, what would you need to make 25 Big Macs? Well, you need to look at this. It takes 2 patties to make 1. So we're going to need 25 times 2, 50 patties. And it takes 3 pieces of bread to make 1. 25 times 3, we're going to need 75 pieces of bread. Now, let's make it a little bit more complicated. Well, we'll make it a little bit more complicated in a second. This is something we've already done right here. You can take moles, you can change it to mass, you can take moles, you change it to volume, take moles, you change it to particles. We've talked about this a bunch. You did worksheets on this. All we're doing in this unit is adding a middle step. Because you can go from moles to anything in a certain thing. The only thing I'm going to ask you to do in this unit is once you have a balanced equation, you can use the coefficients to go from the moles of one thing to the moles of something entirely different. So you can figure out, if I tell you how many atoms of one thing, you can go through this map and figure out the grams on something else or the volume on something else, because you can switch the substance that you're talking about if you have a balanced equation, moles to moles. So let's look at an example. Some titanium oxide with some chlorine with some carbon. You guys know how to balance, so we'll go through this pretty quick. 1 titanium, 2 oxygens, 3 oxygens, we got to balance oxygens, 2 chlorines, 4 chlorines, and we got to balance this guy, bam, 4 oxygens, 2 and 2, 4 oxygens, 2 titaniums, because you need those 2 titaniums there. That makes 8 chlorines, so we're going to need 4 chlorines there. 4 times 2 is 8, 2 times 4 is 8, and then 2 plus 1 is 3 carbons, 3 carbons. All right, so that was a kind of a complicated balance one, but I did it pretty quick there. So let's check out a question. How many moles of chlorine will react with 4.55 moles of carbon? So you're going to start this out the same way that you've been starting things out all year. You're going to write down exactly what you have. 4.55 moles of carbon. Bam, there it is. Then you draw your tool. Draw a fraction with a parentheses around it. Bam, there it is. 4.55 moles of carbon. Now I got moles of carbon. I don't want moles of carbon. Where do they go? Bam. I don't want moles of carbon. They go on the bottom. I want moles of chlorine. They go on top. Now, when I do this, I just write moles of carbon and moles of chlorine and then figure out my numbers. Because where did those numbers come from? 3 and 4. Let's check it out. Moles of carbon, bam, 3 moles of carbon. Moles of chlorine, bam, 4 moles of chlorine. Now, a lot of times I have people say, well, that's not the only carbon up there, Mr. Tyer. There's a carbon and there's a carbon. But I say, this is the only one that is carbon. That is carbon dioxide. That is carbon monoxide. This is the only one that's carbon. Same thing with chlorine. Say, well, chlorine's in 2 places. No, chlorine's in 1 place. That's chlorine. This is titanium chloride. Now you do with your math here just like you normally would. 4.55 times 4, smash that enter button, and then divide it by 3, and you end up with 6.07 moles of chlorine. Let's look at another example. What mass of titanium 4 oxide is going to react with 4.55 moles of carbon? So you're going to start off the exact same way, 4.55 moles of carbon. But this time, we're going to go from moles of carbon to moles of titanium oxide, and then change my moles of titanium oxide to mass, which is grams. So we're going to need 2 steps. Bam, 2 steps. Moles of carbon on the bottom, moles of what we want, titanium oxide on the top, 3 moles of carbon, 2 moles of titanium oxide. Now, if we stop right there, we'll have moles of titanium oxide will be my answer. But remember, we're not looking for moles. We're looking for mass. So you do this next step just like we've done all year. You just take your moles and change them to grams, moles on the bottom, grams on top, and you get your grams from the periodic table. And I'll let you guys look that up. For titanium, you have 204.8, For titanium, you have 47.9 grams, and for oxygen you have 16, but you have 2 oxygen, so you do that math, and you end up with 79.9 grams of titanium oxide. Now, you see there's only 1 mole because you got your number off the periodic table. The only time you have something different than 1 mole is when you're going from moles of one thing to moles of something different, where you use your numbers in the periodic table. 1 mole came off the periodic table, 79.9 grams of this guy. Now checking out how we do this math. 4.55 times 2 times 79.9. All our multiplication first. Smash that enter button. Divided by 3. 242 grams. Now make sure you're following along with a calculator here, guys. Don't just take my word for it. The person when I made this slide, I might have messed up my math. So make sure that you guys are doing this math as well. All right, and feel free to pause too, because you guys know I talk fast. Let's carry on. So let's look at a different one. How many molecules of titanium 4 chloride can be made from 115 grams of titanium 4 oxide? Now, if you notice, we just did titanium oxide, so we already know the grams of titanium oxide. So we're going to start off with 115 grams, just like normal. And this time, we're going from grams of titanium oxide. Always change to moles. If you don't have moles, you always change to moles. Grams of titanium oxide to moles of titanium oxide. Then moles of titanium oxide to moles of what we want, which is titanium chloride. And then moles of titanium chloride to molecules of titanium chloride. So that is 1, 2, 3 steps. 1, 2, 3 steps. Bam, right there. Now, we don't want grams of titanium oxide. They go on the bottom, moles on top. We just, from the previous page, we know it's 79.9 grams of titanium oxide in 1 mole. Now, remember, 1 mole is as long as you're going from grams to moles. When we switch it up and go moles to moles, you're going to use your balanced chemical equation, which is on the previous page. titanium oxide to titanium chloride, look at what the ratio is, 2 to 2. Bam. Now, we're going to do something interesting with math here, and you could probably guess in just a second right there. But we don't want moles, we want molecules. And if you remember back in the day, I'm going to put moles on the bottom, molecules on top. My magic number for molecules in a mole, 6.02 times 10 to the 23rd. All right, now I mentioned we could do something interesting with the math here. 2 over 2 is the same thing as 1. So I can completely ignore my 2's and just say 115 times 6.02 E23, smash my enter button, divided by 79.9. 8.7 times 10 to the 23 molecules of titanium chloride. So some helpful reminders about this. You got to use your coefficients from the equation only when you're crossing the middle bridge, only when you're going from one thing to another. Everything else, unless you're changing what you have, which is right here, everything else is 1 mole. A lot of people make mistakes. A lot of people make mistakes going, putting 2 moles here or 2 moles here. The only time you have more than 1 mole is when you're going from moles to moles. Right? The middle bridge conversion factor is the only one that has 2 different substances. The only way you can change what your substance is to go from moles of one thing to moles of something different. Every other thing you have to go with the same substance. The units at the end of each bridge being crossed appear in the conversion factor for that bridge. That's pretty straightforward. We already talked about that a bunch. And we got another example here. So I would encourage you to pause this and try to work this one on your own, but you're welcome to keep following along, and I'll rock and roll with you as well. So this one's already balanced. We want to know how many molecules of nickel phosphide, this guy, are going to react with excess iridium. Now, anytime it says excess, that means you're not going to run out, which means it doesn't matter how much you have. What it wants to know is the mass of iridium phosphide, which is this guy right here. So we have that many molecules of this. We want to know how many grams of this. So we're going to change molecules of this to moles of this to moles of this, and then moles of this to grams of this. 3 steps. Write down what you got. Bam, there it is. And then hook me up with 3 steps. There we go. Don't want molecules, they go on the bottom. I want moles. Magic number for molecules, there it is. Remember, 1 mole because I'm not changing yet. I'm going to change here. Moles of nickel phosphide on the bottom. What number's right here? A big stinky 1. And then moles of what we want on top, 2 on the top. Don't want moles, I want grams. Moles on the bottom, grams on top. Look at your periodic table. Grams of iridium on the top, grams of phosphorus. Add them together, iridium and phosphorus. Iridium, looking on the periodic table real quick, is number, where is that fool? Iridium, where are you, baby? Iridium's number 77, it's 192.2, and phosphorus is 31. So do that math real quick. You end up with 223.2 over 1. Math it up, you got 5.33 E28 times 2 times 223.2, smash the enter button, divided by 6.02 E23. There you go. That's a lot of grams. Over almost 4 million grams of iridium phosphide from that question. And I'm going to fly through this one really fast because I'm running out of time for what I want to do today. I'm trying to find my time so I don't talk too long here. All right. How many grams of iridium will react? How many grams of iridium, chow, will react with 465 grams of nickel phosphide, chow. All right, 465 grams. Changing that to moles, grams on the bottom, moles on top. Do the math for that grams. Bam, there it is for you. 1 mole of this guy. I don't want moles of that guy. I want moles of that guy. 1 on the bottom, 2 on top. And then I don't want moles of iridium. I want grams of iridium. Moles of iridium on the bottom. Grams of iridium, which we just said was 192.2 on the top. There we go. 465 times 2 times 192.2. smash the enter button, divided by 238.1, do a little dance. You got 751 grams of iridium. It's not that bad, is it? All right, another example here for you. How many moles of nickel, this fool, are produced if you have 8.75 times 10 to the 25th atoms of iridium? That fool. All right, now this one's moles, so it saves us a step because I'm going to change atoms of this guy to moles, and then moles of this guy to moles of this guy. 2 steps. Don't want atoms, they go on the bottom. I want moles, they go on the top. Magic number for atoms, 6.02 times 10 to the 23. Don't want moles of that guy, they go on the bottom. I want moles of this guy, they go on top, 3 over 2. Math it up. Now here's an interesting thing about this math. You gotta do all your multiplying before you do your dividing. So I'm gonna say 8.7 E25 times 3, and then 6.02 E23 times 2, and then divide those together. Now, how I do that in a calculator is I say 8.7 E25 times 3, smash my enter button, and then divide, start parentheses, 6.02 E23 times 2, close parentheses, smash your enter button. If you do it right, you should come up with about 217 moles. And just in case you're curious, nice pretty picture of a nickel and a nice pretty picture of iridium. All right. What volume of hydrogen gas is liberated at standard temperature and pressure if 50 grams of zinc react with excess hydrochloric acid? Now, first thing we need here is a balanced chemical equation. Okay? So I'm going to build you one real quick. Well, I guess I'm not. Well, we're going to change grams to moles real quick. But we need a balanced chemical equation, okay? So zinc is reacting with hydrochloric acid, so zinc plus hydrochloric acid. That zinc is going to hook up with, it's a single replacement reaction. Hydrogen gas goes off by itself, and you have zinc chloride. Bam, there it is. Right? I don't ever expect you to be able to make this on your own. I'll always give it to you, no stress. We need to balance this fool. 1 zinc, 1 hydrogen, 2 hydrogens, 2 chlorines, 2 chlorines. Everybody's happy. All right, so let's look. We don't want moles of zinc. They go on the bottom. We want moles of hydrogen gas, 1 to 1. Life is good. Okay. I don't want moles of hydrogen gas. I want volume. If you remember the box from my classroom, the magic number for volume is 22.4. So 1 goes on the bottom, 22.4 on top. Do a little dance, do some math. 50 times 22.4. Smash your enter button, divided by 65.4, and you got a happy little answer, 17.1 liters. All right, guys, I'm going to stop here. I'm going to leave this one up here on the board and let you solve it if you want to. At STP, how many molecules of oxygen react with 632 milliliters of butane? I know that's decimeters cubed, but milliliters is the same thing. Actually, liters is the same thing. But I'll give you your balanced chemical equation real quick. So we have butane, just like a lighter, combining with oxygen. And we're going to see how much carbon dioxide and water you make. Remember, it's combustion reaction, a special type of reaction. So balance that, find the answer, and remember decimeters cubed is the same thing as liters, so 22.4 is your magic number. All right, guys, it's been great, and I hope you are, like I said, I'm definitely missing you, and hope to see you soon. Bye-bye.